Welcome to The Explainer. Today, we're diving into a massive, frankly game-changing shift in the legal profession. We are transforming contracts from static, dusty paper documents into active, executing performances. If the language of software engineering feels completely alien to your legal practice right now, don't worry, you are in exactly the right place.
So, let's just start with a really fundamental question. Why do brilliant legal professionals, people who absolutely excel at highly complex logic and conditional reasoning, hit a brick wall when faced with basic programming syntax? Think about it. As a lawyer, you're already an expert in obligations, conditions, and structured thinking. Yet, if we put a few lines of basic computer code in front of you, that expertise can just suddenly short-circuit. Today, we're going to untangle exactly why that happens and give you the tools to finally bridge that gap.
Here's a quick look at our agenda. We'll start with the grammatical hurdle, then look at assigning with a single equals, evaluating with double equals, how to read right to left, and finally, the future of automated law.
All right, let's jump right into section 1, the grammatical hurdle, and viewing code as a performance.
To bridge the gap between law and computer science, we've got to fundamentally shift our perspective. We have to move away from the static paper drafting mindset and adopt what we'll call a calculus mindset. And that really starts with understanding the concept of a runtime. In software, a runtime is the live execution of instructions. If you think about it, this perfectly mirrors the legal concept of a performance, the actual fulfillment of contractual obligations. When you draft a contract, you're essentially designing a system beforehand. When that contract is executed, you're literally hitting play and watching that stage performance play out start to finish.
Let's put that into perspective. Think about a single data entry just sitting passively inside a standard spreadsheet. It just sits there, right? It statically represents a fact. But in a computational environment, like an actively running script, that exact same piece of data is part of a dynamic, living system. It triggers actions, it fulfills conditions, and it actively drives the performance forward. Grasping this difference between passive assets and active instructions is absolutely your first key to computational literacy.
Which brings us to section 2, assigning with single equals.
In a computational environment, the single equals sign represents variable assignment. Honestly, this is one of the biggest conceptual hurdles for lawyers to overcome. In normal English prose, or even just basic math, an equal sign is a declaration of fact. You're saying X is Y. But in programming syntax, a single equal sign is an active instruction. It means taking the data on the right and physically packing it into the container on the left, very much like putting a physical item into a box. It is active machinery, guys, not a passive statement of equality.
And that leads us perfectly into section 3, evaluating with double equals.
Okay, pay close attention here, because this is the core contrast you absolutely have to unlearn. As we just saw, a single equal sign assigns a value. It's an active instruction, putting an item into a box. But a double equal sign evaluates a condition, much like placing two different items on a scale to weigh them. It's fundamentally asking a question. Are these two things identical? If a lawyer looks at a single equals and assumes it means equality, well, the entire logic of the document collapses. Untangling this specific difference between an active command and an evaluating question is literally the defining threshold of cracking computational legalese.
When you use that double equals sign, it acts as a strict Boolean gate. It yields only one of two possible answers, true or false. And this strict binary is exactly how we have to translate ambiguous and/or legal conditions into deterministic code. In traditional legal drafting, scope ambiguities can totally hide within our prose. But a computer? It cannot process ambiguity. The double equals forces us to collapse those broad, fuzzy clauses into strict, true or false logical gates that a machine can execute without any hesitation.
Let's look at how this builds a larger bridge between our two disciplines. Notice how legal formats actually map perfectly to strict machinery, a standard clause and subclause format. That translates directly to nested if-else logic. A contractual obligation translates to a software runtime. And what about when a contract requires a party to perform repeated, recurrent tasks? Well, in computational syntax, those become for loops, explicitly automating that repetition. It's the same logic, just a different vocabulary.
All right, let's look at section 4, reading right to left, which is a major cognitive shift.
To overcome your English prose biases, you literally have to train your legal eye to process information backwards. I want you to treat this like a brain training exercise. When you see a variable assignment, that single equal sign, you do not read it from left to right like a book. Step 1, your eyes must jump to the value on the far right side of the equation.
Step 2, you recognize the active assignment instruction. And Step 3, you move left, understanding that the value is being stored in the variable container on the left. It's a mechanical way of reading, and yeah, it takes some practice, but it instantly unlocks your ability to actually comprehend the logic of execution.
Finally, Section 5, the future of automated law. We're currently transitioning through 3 historical stages of law, and it's best understood through a transportation metaphor. Historically, we practiced direct law, which is traditional analog lawyering, basically the horse and buggy era. Today, we're in the era of mechanized law. Think of this as early cars. We've introduced legal engineering, which brings hyperspeed and automation. But frankly, it desperately needs new regulatory guardrails, just like early cars needed traffic laws. The final stage we're racing toward is automated law, the autonomous, self-executing Waymos of the legal world, completely governed by the deterministic logic we've been discussing today.
Because legal deliverables are rapidly evolving into software, the career paths in our profession are splitting into 2 very distinct directions. You're basically standing at a fork in the road right now. Down one path, we have the engineering route. This involves developers acting as specialized legal authorities, much like how patent agents operate today. Down the other path, we have the lawyering route. This will consist of traditional practitioners who just naturally operate with programming syntax in their everyday practice, because the line between natural language and computational execution has effectively vanished.
So, as we wrap up this explainer, you really have to ask yourself a critical question. Are you going to cling to static paper and the fuzzy ambiguities of traditional prose? Or are you ready to overcome these grammatical hurdles, master the mechanics of assignment versus evaluation, and engineer the automated runtimes of tomorrow? The future of the profession is written in syntax, my friends. It is time to learn the language. Thanks for joining me.